All right, we are ready to start our first lesson for Scala programming. Instead of spending too much time on a lot of theory or a lot of documentation, we will dive directly into coding. But there are a few things that are worth mentioning. The material that we'll be covering in this course will be coming from this particular book here, and I happen to be the author of this book. So we are in a very good hand. And then before starting any coding activity, we need to install Scala. So if you go to this site here, scalalang.org, so you get to see a bunch of things: documentation, downloads, community libraries, like in any other, programming languages. And then if you click on download, then you see the latest available version here. 2.13.1 is the latest available version. And then 2.14 is going to be the conversion version from version 2 to version 3. Actually, Scala 3.0 is coming. Now here you get the instruction for installation. So if you follow these instructions, then you should be able to actually do the installation activities. And it also tells us that it needs JDK. That's important to keep in mind, that JDK is required in order to run Scala programming, because Scala is a JVM language. Okay, once you do the installation, once you follow this documentation, then we are ready to start Scala programming. So since I did this activity before, and this is a MacBook, as you can see, if you now check where we are, so I'm in this my users home directory. This is my user ID, and I am in my home folder. And if I check my profile, this profile, I see this particular line here, Scala home. So it's pointing to my Scala installation. And then we're adding the bin folder to the path. So that means my Scala, when this computer is booted, it basically reads all these paths, all these folders, in addition to the default folders that macOS is required to read, and then it keeps that into its memory, so that all the commands associated will be available. So that's all is needed. And then if you want to test whether Scala is properly installed or not, you can test that by typing just Scala. That's the Scala interpreter. Okay, so we type that, and if you see the version, at least some information, something similar to what is being shown here, then you know that Scala is properly installed. Actually, it went to the Scala REPL. We will talk about REPL later, but at this time we'll just quit from REPL. Quit. Okay, we came back, or you could just say Scala version. It will give you the version. And then one more thing to check is also the compiler. With the compiler, this is the Scala interpreter, the runtime environment. And then the other one that is important is the compiler that is required to compile programs. So that one we can check by typing Scala C for compiler, and then same thing, version. Now you see that particular version is shown here. So in my machine, this is the version that was installed. So I will use this unless it is absolutely required to use some later versions for certain features. But you can use any version, because these programs are compatible. Most of the programs that we write in this course are compatible. If anything is not compatible, then I will show you how to kind of write code in that particular version of the compiler. So now with this, we are ready to actually start programming. So let's jump into programming. For that, I'm just going to a particular folder, which is a temp folder here, and then let's check what is here. So a bunch of things that we don't have to worry about. So what I am going to do is in this lecture, I will create a full you know couple of maybe a little more uh, full-blown Scala programs, and then I'll show you how to compile, and I'll show you how to run. And I chose to not to use any IDE like IntelliJ or Eclipse, because IDEs hide certain things, and then it may not be clear for us how actually the whole cycle of program creation to compiling to running actually happening, because IDEs usually they have a link to the compiler, they have a link to the runtime environment, and they do that for us. And it's certainly very helpful if you have a large programs. If you're working for a professional projects, it's certainly recommended. But there are different ways of doing things. For example, if you happen to work at Google, one of the finest company for software engineering work, um, you know, uh, they don't necessarily use IDEs all the time. You write programs using some sort of text editors, some sort of web-based text editors, and then there are tools to link all your programs and package them. So it's certainly very helpful to write programs using some text editors. Initially, it might sound a little bit counterintuitive, but it'll make sense when you actually start working for some of the finest high-tech companies. The root is basically Linux for all of this. So that's why we are seeing terminal here, and then we'll use the VI. And there is a reason. VI is a simple editor, originally started in 1960s. And again, it may sound counterintuitive to use VI. Uh, I chose to use VI for the first lesson primarily because if you again happen to work for uh, very best high-tech companies, you will thank me for using VI. Not only for programmers, if you happen to work in other jobs like system administration or any other jobs, this is going to be handy. And the primary reason that I have seen is this editor is available in any flavor of Unix system. Linux being one of the variations of the Unix, obviously. So if you know how to use VI editor, you will always have editor in any Unix environment. So that is the reason. Otherwise, there are fancy editors that I've installed in this machine also that I could use, but that may not serve the purpose best at this point. But for efficiency, you can use any editor if you are not comfortable with VI. But there are certain benefits, and VI initially it might look like it's will be slow to work with the tool, but in fact it is faster than using any GUI tools, and that comes by practice. So with that, let's get started with the program. So I'll just start VI. That's to start the VI editor, and then let's name the program, the file name. Actually, it doesn't have to be the program name. We'll see shortly what is the difference between file name and then the the entity that we are going to run. Now we are just giving the file name. In that file we can house many items, like we can have class, we can have multiple classes, a bunch of methods if you're writing functional programs. Now let's just write let's just give some name. My first program. Okay, dot, and extensions will be Scala. Okay, let's do that. So we are in the editor, VI editor here. If you move it around, you can see that. So now let's if we press I here, it goes to insert mode. Now I can start typing my program. So now I can okay, in this, let me just type the program, and then we'll talk about its components there. So I'm going to write some program that can be executed. So for that I need a object, not class, object here, because that's the one that will have a main method, and then I can run that. So object, and then object name, So I can give any name here, and some meaningful name. So maybe test program, test object, and then it starts with curly brace and then it ends with another curly brace there. So it's nice to nice to write closing curly brace after this one. It's a good habit, because when you write complex program, it's very easy to forget them. So now we're going to create a method uh, inside this test object, and that method is going to be the main method, main, and then it takes arguments that's of type array, and then that's array of string. Even though we are not going to pass any argument in this first program, we still have to give this syntactical structure, so that program doesn't come with compilation error. And then also we are not returning anything, so we're going to write unit is equal to, that's how we define this main method. And again, I'm repeating this particular behavior, which is a good practice. Okay, so I'm closing the definition of the main method there. Okay, now obviously it's empty, so I need to fill it. So what I would like to do in this first program is actually just print something like hello world or welcome to programming or something like that. So for that I just write print, and then inside my double quotes I just write any string. I can write any string. I'll just say welcome to Scala programming. That is a complete runnable program. So now I'm going to save it. Okay, W for write, Q for quit, because I'm going to save, and also I'm going to exit because I would like to compile from my terminal. Okay, I exited. Now if I do ls -l, and then my Unix environment, this is MacBook in Unix, which obviously is one of the flavors of the Unix operating system. I don't have to necessarily type everything, so it has auto completion. Now if I do that, I see the timestamp when it was. You see the date here, and also the timestamp. This is 5:43. That's the right timing, and it shows all of the detailed file size and everything. But for now, file size is not that important, but we just make sure that the Scala file is there. Now, if I want to compile it, and I use the compiler this way, Scala C for Scala compiler, and remember that this compiler is available because I had a path specified in my bash profile, and that's how when I started the terminal, it loaded all the required libraries, the Scala libraries for me, so that I can use compiler. So Scala C, and then I type my file name. That's my file name. If there are no errors, it's going to compile everything, and it'll just keep quiet. If there are errors, it's going to tell us what errors are there. So since it did not say anything, that means it looks like it went fine, but I have to verify that. How do I verify it? I get a list. I list. Now I need to remember what was the name of object in my file, inside this file, inside this file, this particular file that we actually compiled. If you don't remember, then you can do cat and that file name. It will just print the content of that file here in the console itself. So my object name is test object. Let's do that. ls -l test object dot, it should be a class file. Once it is compiled, we see a class file, and then anything with that, let's see. So there is only one because I didn't have anything else here. So it's compiled successfully. We didn't have any compilation error. Now we are going to run this program. So when we run it, we are going to see this particular string, because that's the one that we wanted the program to print in the console. So now to run the program, say Scala, the interpreter. You can interpret the class file, But if you go to REPL, which we'll talk about later, that doesn't need a complete program. So now let's just run this particular class file test class. You don't need the dot class extension to run it. Actually, if you do that, it might throw an error. Let's just run it, and now we will see. Yeah, we actually show it. So you see this one. Welcome to Scala programming. It came to the, and then I have my prompt here immediately printed after that because I had this print there because I didn't have a new line. That's why it's coming in the same line. But if I want to have it in the new line, what I need to do is I need to go back to my with the up arrow I can go to my previous commands, and that one, let me actually type it. Let me cancel this and type it so that we can clear it. bi, just to make it clear, and that's my first program, Scala. Okay, I need a new line, so what I'm going to do is ln, print ln. What it does is it prints this string, this whole string, whatever is inside the code, and then after that it also prints the new line, so that anything that is printed, that is supposed to be printed after this, the content inside the code is printed, that comes in the next line because there is a new line command as well. So this is one way to kind of tweak the program and learn by actually coding. That's one of the best way of learning programming. Okay, I'm doing this one again, WQ, and then now I need to, since I made changes to my program, I need to recompile it. I can either do up arrow and then get my command, or I can just type Scala C, my first program, compile, no compilation error, Scala CALA, and then that object, I don't need the dot class, I just run it. This time it printed the string and then it printed my prompt in the new line as we expected. So this basically completes the first complete fully runnable Scala program. So now now what we can do is, let's go to the program, go back to the program, and have a quick understanding of the program at this level. Actually, each elements, all the required elements of the program will be discussed in the coming chapters, because this course is all about Scala programming. But now let's just have some minimum components so that we can continue writing complete programs for this particular session. So object in Scala, if you have an object, that's is a singleton, and we can write main method inside the object, and then we can, if you have a main method, then we can run this program. That's the need for us actually, since we want to run and see. We went for object, and then so that we could have a main method in it. Okay, inside my class, if I do that, it does not compile, which is a little bit different from other programming languages. If you're familiar with Java programming language, you actually don't have got the object keyword there, at least as of Java 1.8. You can have everything in the class, and you compile that class. If you have a main method, it automatically understands, and the entry point will be the main method. But in Scala, at least for this version, the version that we are using now, 2.11.7, well, let's check what version, just to be sure. Scala version, yeah, 2.11.7, that's correct. So for this version, at least this is true. Okay, but let's not worry about all those things now, because we will be dealing with that later, and even in the advanced part for this course. Actually, this course, this is part 1. We have part 2 as well. Okay. Anyway, so now, and then after object, that's the keyword, we have this name. It can be any valid identifier. So but it's a good idea to give a the meaningful name here, and then you need a opening brace and closing brace. Okay, so and it's, as you saw earlier, that it's good to develop a habit of having the pair when you start typing it. Okay, but that's up to you. Now next is def. Def is also the keyword. You're defining a main method. That's all it's telling. It has to be the same spelling. And then main method takes one argument, and it can be any string. This args, it can be any name, any value identifier, and then followed by colon. Anything that comes after colon is a type. What it's telling is the argument is of type array, like the array in any other programming languages, if you're familiar with that. If you are not, then array is a collection of similar data types. It's like a container to be, kind of to simplify it. It's a container, it contains this string. That's what it's telling it. It's the container that can contain multiple strings. Okay, and then you close the parenthesis. Anything that is inside this parenthesis is known as parameter list. And then again we have a colon, and after that there is a type, and this type is for the method. Actually, the earlier type, this type was for the argument, and the type outside this parenthesis is for the method, because we want to know, or compiler wants to know, what will be the return type of this main method. We're not returning anything, so we just type unit, and unit is also optional. If you are not returning anything, you may just leave it empty, but let's not worry about that for now. Let's just develop the habit of having return type there, so that we don't forget when it's actually needed, or we want to enforce the return type. And then method definition also starts with the curly braces and ends with the curly brace, and inside those curly braces we can have any number of statements. So the one that I have here is println, and then parentheses, and inside the code I have a string, the message. Okay, and then I've closed the parentheses. So that's how we write this is one of the statements of a Scala programming language, is the println statement. Okay, so that's all is needed to have a hello world program in Scala, and that should be good enough. We ran it, we modified, we compiled, we ran, and then we want to modify it, and then we saw the modified output through recompiling and rerunning it. So that basically completes the first program for this section. Now we will see a few other programs. Let's just go out by typing now. I didn't need to save it, so I'm just quitting it. Okay, I'm outside. We'll write a couple more programs. One that takes or we could write, actually we could use one program and then we could do two different kind of things. But let's for the sake of practice, let's just do two. Let's write two programs. One, I will just say my second program dot Scala. So in this program, what we are going to do is we will define here in the program two integers. Okay, and again we'll talk about data types and everything later in later session. This section, or this session, whatever you want to call it, is to give you a flavor of the Scala programming. Okay, so that you can write a complete program and then just play with it. Later on we might use a REPL, the read, evaluate, print loop, also well, you could say it's like interpreter, but let's not get into detail of that now because it might be overwhelming. That one we'll discuss later. So now let's write a program, Scala program, in which we define two integers, and then we print the sum of those two integers. Let's do that quickly. Like before, we do object. This time I'm going to say sum, because, or I will say find sum or something like as a sum, right? Okay, or summation, sum per shortcut. Okay, and now I'm going a little bit faster. It can be anything, array, string, like before. is equal to, I'm defining my method here. Okay, now I need to slow down a little bit because I'm going to introduce something new. That is, I'm going to define two numbers. My first number is, or let me first type it. Uh, I'm defining two constants actually, you know. So for that, for Scala, I need to tell what it is. So I'm telling value. Value means that's something that is a value actually, which is very clear. Well, it's a constant, and we'll talk about constant later. That means it cannot be changed. Okay. Now I don't have the need to change it. That's why I'm defining it as a constant. Also, it's a good practice to program with constants. That will come, over a period of time. I know when you program a lot in Scala or any other programming languages, and also when you work in the industry for a long time. And if you have already worked, then you certainly know what is the importance of using constants. Especially it is a safe way of programming in a distributed environment. Okay, for now I think that's more than sufficient. Let's say first number here. Number is equal to, I'm going to define, okay, 5. And in Scala, I don't need a semicolon. This is optional. If I don't want to write it, I don't write it. If I want to, I can. And my second number is equal to any number. It's fine. And next one, let's define one more, one more constant here. Just for clarity, actually it's not needed. We can do that. We can become more efficient. But for clarity, I'll say sum is equal to first number plus second number. Okay. And next I'm going to print it. Print ln. I'm going to do ln. I'll say sum is equal to, and I'm going to say plus sum. And this time, let's just quickly talk about it here before we compile. So this line over here, you see, I'm defining a first number, which is 5. This is a constant. Val means constant. And this first number is an identifier. Second number is also identifier. Number 7 is a constant. That's the definition for this, my second number. And in this particular line over here, I am actually finding the sum of these two numbers. And this not look strange because it's pretty much like any other arithmetic. The only difference is I need to assign it to a third variable. Well, for this program at least, I could do it without assigning. There is a way to do it, but since this is our first session, we like to have as simple programs as possible. So the sum is going to hold whatever is the sum of value that is actually pointed referred by the identifier first number, and another identifier over there on the right hand side of the plus operator, which is second number. And I'm going to print that. In my print statement, if you see it closely, I have something inside the quote. Anything inside the quote is going to be printed as it is. So we'll see sum is equal to, and then this plus here, this is not a addition operator, because this is something is called overloading that we'll talk about later. But for now, what it does, I could have a space here just for clarity. I just remember it, so that of just adding there. It doesn't make a difference in terms of compilation. It's for program readability. Now this one just prints whatever is inside this quote over here, and then whatever is the value of this variable, the sum variable, sum variable. Okay, so our value is actually 7 plus 5, which is 12. Okay, now let's save it, let's compile it, and if everything is right, no compilation error, when you run it, we should be able to see sum is equal to 7. Let's do it. Okay, I'm going to save and quit at the same time, and I'm going to compile this. What is my file name? My second program, Scala C. Right, my second program. Yes, Cala. That's the wrong command. Yes, Calac. My second program. You see, when you mistype it, it's going to tell you. command not found because SCALC is not the thing that we loaded in the memory because it's Scala C, that's the correct name. So computer does not know what SCALC is. Okay, so let's compile it. Let's see. Okay, no errors. So it looks like it's compiled. Now to run it, if you remember, if you don't remember the object name, you can always print it here. If you remember, you can just run it. I would like to just show you here cat my second program, and my object name is sum, so I'm going to run that sum here. Okay, sum. Okay, so we saw 12 exactly. Okay, so we already did write 2 programs. Now we're going to write one more program, and in that program we're going to take input from the keyboard actually, because that's something beginning programmers they like to do. They like to get something from the keyboard, and then they like to process that and then again show it in the console. That's something that's fun actually. If you're developing any game or anything like that, we try to take input from the keyboard. And also when you're doing actually work with computers, you interact with computers a lot using keyboards, at least up to this point in time. Maybe in the future you will have computers that work more with some other means of operating, like you touch the screen and then you interact with it. But our conventional computers like laptops and other computers up to this point, they work heavily with the keyboard, so we're going to make use of that. Now let's write a third program, our third program in this session, which actually takes input from the keyboard and then does summation again and then prints the sum in the console. And for clarity, I'm going to start a new program from the scratch. I could actually modify the second program, but instead of doing that, I am actually going to write a complete program called vi my third. Let's see, that is right actually. Third. I thought I made a spelling mistake. So my third program does Scala. Okay, I'm in the insert mode. My object name object, that's going to be, let's say, let's call it some. I'm just going to just call it input sum. Okay, this doesn't look like a very meaningful name, but it is fine. It is syntactically fine. Okay, and my opening brace, curly brace. Okay, I'm going to define my main method here like before, nothing new here. Array string and my return type here, and I'm going to close my method definition. In this program, I'm going to read something from the keyboard, and I need a message. So for that message, I'm going to print something in the keyboard. I say enter your first number. Okay, and then I'm going to read that. When I read it, I want to assign it to a number. I will just say a here. I could say first number. Okay, is equal to read int, read integer value. I'm specifying. Okay, that should be integer. If it's not integer, it's going to throw error. Okay, and then similarly, I'm going to do that for my second number. Enter the second number. Okay, and again, well, number is equal to, I'm going to read int again. Okay, and this, and then I can do sum is equal to first number plus second number. Is pretty much like before, whatever we did before. And then print sum is equal to plus sum. That's it. Okay, but there is one more thing to add here. That is, here we have readin that we did not see before. Now where does this readin come from? Because this doesn't come by default, like println and all those things, they come by default. But this thing we need to explicitly say where it comes from, and this is something that we need to actually remember. Okay, and that's true for every programmer, whether we are experienced programmers or not. We need to remember it. Okay, so it comes by practice again. So this one comes from Scala IO stdin dot. I'm going to do this one. What it means is import, and then this underscore means everything is like a star in, you know, in let's say if you know regular expressions, or if you you know, most of the times, like we did ALS before, if we did star, that means I don't care everything. It means everything. Okay, I don't care what the characters are after this. If you're doing ls or this kind of commands, here it means, you know, from this particular IO package, you know, and then from this stdin, we can see what this is actually. I think it's very, not here, but over here, Scala IO stdin, search it, and this is another way of learning it. See, it comes, Google is very handy. A lot of people these days, they Google in order to learn programming. Let's see what it is. So it is actually object. Okay, it's object that extends, you know, you can keep going actually, and these are the methods that they call value members. You know, you could also say the methods. So you should be able to find that if you search here, read int, yeah, that's where it is. Okay, it reads integer, and that's the return type. Okay, that's something that we don't need here. Okay, that's it. That's the package over there, and we're in that object, right? All right, and you can see another stdin there, and let's see what that stdin is actually. Okay, if you can see it here, let's see, stdin. Okay, we're seeing the definition, and we're seeing that, okay, we're seeing what it is. It's like an interface. Trait is like interface. Traits is actually the interface for Scala programs. Okay, let's not worry about these things. We can, for now, we can just forget. I just thought of showing you so that you have some flavor of you know, Scala learning, typical way of learning. That's how I learn when I don't know something. Okay, and that's how I think you'll be learning if you don't know things, because it's hard to kind of get everything from, you know, video lessons or, you know, any prepared material. Usually we'll have to Google, we'll have to see the documentation over here. We see the documentation over here. That's the way of learning. So now let's go back. Okay, one thing to note that is, I think by mistake I created another tab. I don't need it now, but it's nice to have it actually. I can make use of it, but I can go back here. If I want to make use of it, how I make use of it is I just save it. Okay, I save it, but I didn't quit it. I didn't quit it because if I want to come back, I don't have to open it back. I have another tab here, but I need to go to the same place here. 10. Where am I? Okay, I'm already in the 10. So you see my program, my third program over here. Very nice. I'm going to compile it now over here. Okay, and my program, see, it's open there. And I'm on another tab. I'm going to compile it. Scala C. Let's see if it completes it. See, it looks like it completes actually. See, Scala, it completed, it went up to that point, but I'm in the compiler, not the interpreter. My third program. Okay, let's see if it has any error. Oh, beautiful, beautiful, no errors. All right, I'm ready to run it now. I didn't type it because I already have it open. So that's my name of the object. Okay, I'm going to run it and I'm going to see it. Let's do that. Scala. Okay, it's going to ask me the first number because we have, yeah, it's we seeing the message here. Enter your first number over here, right? This number, and over here it's printing the same message. I'm going to enter my first number here, 6. Okay, and after this I press enter, so it's giving a new line and another message over here. Once I press enter, it's going to print enter your second number, and I'll have to enter my second number, and it's going to do the addition, the summation, and then it's going to print the sum. Okay, so now let's go back to the second tab. Okay, I by mistake started the second tab, but it turned out that it's handy actually. Okay, so that is one more learning over here, how to make use of multiple tabs so that you don't have to actually keep closing your program and keep reopening your program. My first number is 6. Coming back and enter your second number, that's the message. I'm going to enter 7, so the sum is going to be 6 plus 7, which is 13, and the 13 is printed right here, and then my prompt there. All right, so we did three. We wrote 3 programs. I think that should be sufficient for this first session. We got a pretty good picture of what what Scala programs look like, and then in the coming session we'll discuss about each element of Scala programs one by one. It's going to be pretty interesting actually, and you can see that I get a message for ICAO protection, and that's useful for you as well, though it's not needed for this particular programming session, but it's not, it's not, it's good for your health actually. Okay, so you need to take a break, so we will take break now. So I'll see you in the next session. Thank you very much for attending this session.